Can you guess how many multiple choice questions I have solved in this video? 10, 20, 30? No, I have solved 50 multiple choice questions for you. Welcome to my physics channel. In this video, I am going to present a comprehensive model question paper of physics useful for MHCET engineering entrance examination. The question appearing in this model paper also useful for any other engineering CET, NEET examination and JEE mains. This model question paper has 45 solved multiple choice questions and 5 practice questions. 45 questions with solution covering important physics concept and problem solving technique. I encourage you to solve this question paper. If you solve this question paper, you will know what are the type of question appear in the MHCET examination, level of the questions, the depth of the questions, the intensity of difficulty, so that you will know how to study and what are the important points, nook and corners to be paid attention for upcoming examinations. So wish you best luck and solve this question paper to score more in your upcoming examination. So let's start today's video. Question number 1. Angle between wavefront and wave normal is 0 degrees, 90 degrees, 180 degrees and 45 degrees. Along line XY nothing but wavefront, all particles along the line XY oscillate with the same phase, and PQ is wave normal. Angle between wavefront and wave normal is 90 degrees. Therefore, the option B is correct. Question number 2. Displacement current arises due to option A, changing magnetic flux, option B, increasing dielectric constant, option C, changing electric flux, option D, none. Here is the solution. The fictitious current which arises due to changing electric flux is called displacement current. The concept of displacement current was introduced by Maxwell. Displacement current occurs if electric field changes over time. Therefore, option C is correct. Question number 3. A parallel plate air capacitor has capacity 10 microfarads. What will be new capacity if distance between plates is doubled? Option A, 5 microfarad. Option B, remains the same. Option C, 20 microfarad. Option D, 40 microfarad. Solution. Formula for capacitance for parallel plate capacitor is given by AK epsilon naught upon D. So before changing the distance between the plates, C1 be the capacitance given by AK1 epsilon naught upon D1 and case 2 AK2 epsilon upon D2, and it is a being air capacitor, K1 equals to K2 equals to 1, that is a dielectric constant for air. Now the distance is doubled, therefore D2 equals to 2D1. Now C2 upon C1 equals to A K2 epsilon naught upon D2 divided by A K1 epsilon naught upon D1. These terms get cancelled, so we get C2 upon C1 equals to D1 upon D2. Now C2 equals to C1 into D1, and D2 nothing but twice D1, D1 get cancelled. C1 is given as 10 microfarad upon 2, therefore C2 equals to 5 microfarad. Therefore, option A, 5 microfarad is correct answer. Question number 4. Kirchhoff's voltage law is consistent with option A, law of conservation of charge, option B, law of conservation of energy, option C, both A and B, option D, none. In Kirchhoff voltage law, all voltage drops in a closed circuit must be equal to 0. In a closed network or loop, total energy gained per unit charge always equals to total energy lost per unit charge. Hence, Kirchhoff voltage law is consistent with law of conservation of energy. Therefore, option B, law of conservation of energy, is correct option. Question number 5. Dimensional formula for gyromagnetic ratio. Option A, m raised to minus 1, L raised to 0, T raised to 1, I raised to 1. Option B, m raised to 1, L raised to 1, T raised to 1, I raised to 1. Option C, m raised to minus 1, L raised to 1, T raised to 1, I raised to 1. And option D, m raised to 0, L raised to 1, T raised to 1, and I raised to 1. Gyromagnetic ratio is given by m naught upon L naught, where m naught nothing but orbital magnetic moment of the electron and L naught equals to orbital angular moment of the electron. Therefore, gamma naught equals to m naught upon L naught, that is equals to E upon twice me. Therefore, gamma naught equals to charge upon mass. To find out the dimensional formula, we don't need constant. Therefore, selecting charge upon mass. Charge dimensional formula for charge is given by T into I, and mass is nothing but m, which on simplification gives m raised to minus 1, L raised to 0, T raised to 1, and I raised to 1. Therefore, option A is correct. Question number 6. The photoelectric work function for a metal if threshold wavelength for the metal is 3 into 10 raised to minus 7 meters. Option A, 6.63 into 10 raised to minus 19 joules. Option B, 6.63 into 10 raised to minus 32 joules. Option C, 1.69 into 10 raised to minus 19 joules. And option D, 6.63 into 10 raised to minus 9 joules. Photoelectric work function equals to hc upon lambda naught, where h is a Planck constant and c is the velocity of light. That is equals to 6.63 into 10 raised to minus 34, and velocity of light 3 into 10 raised to 8 meter per second, and lambda naught given 3 into 10 raised to minus 7, which on simplification gives 6.63 into 10 raised to minus 19 joules. Therefore, the correct option is option A, that is 6.63 into 10 raised to minus 19 joules. Question number 7. In hydrogen atom, angular momentum of electron in third Bohr orbit is equals to how much? Given h upon 2 pi equals to x kg meter square per second. Option A, 0.3x kg meter square per second. Option B, 9x square kg meter square per second. Option C, 0, and option D, 3x kg meter square per second. Angular momentum of electron L equals to nh upon 2 pi, where n is the third orbit, and also it is given h upon 2 pi equals to x kg meter square per second. Therefore, L equals to n into h upon 2 pi. N is 3 and h upon 2 pi is x. Therefore, L equals to 3x kg meter square per second. Therefore, option D is correct option. Question number 8. In electric and magnetic field, highest deflection shown by dash particles. Option A, beta particles. Option B, gamma particles. Option C, alpha particles. And option D, gamma and beta particles. Solution. Alpha particles are deflected by electric and magnetic field. Their deflection is less than beta particles. Beta particles also deflected by electric and magnetic field, and their deflection is more than alpha particles. Gamma particles are uncharged particles and zero deflection. Therefore, beta particles have highest deflection in presence of electric and magnetic fields. Therefore, the option A, that is the beta particles have highest deflection is correct option. Question number 9. In case of a rectifier circuit, RMS component is X and average value of DC component is Y. Then ripple factor equals to how much? Option A, Y upon X. Option B, XY. Option C, X upon root Y. And option D, X upon Y. Ripple factor equals to RMS value of AC component divided by average value of DC component. Therefore, ripple factor equals to X upon Y. Therefore, option D is correct option. Question number 10. In case of transformer, option A, both coils connected by using resistor. Option B, capacitor is connected between coils. Option C, inductor is connected between coils. Option D, both coils are insulated from each other. Transformer has two coils, primary coils and secondary coil. Transformer works on the principle of mutual electromagnetic induction. Both coils remain untouched. Electrical energy passes from primary coil to secondary coil with the help of mutual electromagnetic induction. Therefore, in case of transformer, both coils are insulated from each other. Therefore, option D is correct option. Question number 11. In a pure resistive AC circuit, resistance is 36 ohms. Power consumed over one complete cycle is 144 watts. Then RMS value of current is option A, root 12 amperes. Option B, 2 amperes. Option C, 4 amperes. And option D, 0.2 amperes. Solution. Power in pure resistive circuit is given by P average equals to R into I RMS square. Therefore, I RMS square equals to P upon R. I RMS equals to under root of P upon R. That is equals to under root of 144 upon 36. Therefore, I RMS value equals to 2 amperes. Therefore, option B, 2 amperes is the RMS value of current. Option B is correct option. Question number 12. There are two polarizers. Second polarizer making 45 degrees with the axis of the first polarizer. Then intensity of light transmitted by the second polarizer. Option A, half. Option B, double. Option C, triple. Option D, infinity. Here the solution, the theta is the angle between transmission axis of two polarizers and theta equals to 45 degrees. Therefore, I2 equals to I1 cos square theta. So I2 equals to I1 and theta is 45 degrees. Therefore, cos 45 whole square. So I2 equals to I1 into 1 upon 2 implies I2 equals to I1 upon 2. That is the intensity of transmitted light becomes half. Therefore, option A is correct option. Question number 13. Sensitivity of a galvanometer can be increased by option A, decreasing radius. Option B, increasing number of turns. Option C, both A and B. Option D, none. Sensitivity of galvanometer proportional to mu naught n upon 2R BH implies sensitivity increases with number of turns and sensitivity increases if the radius decreases and sensitivity increases if BH decreases. Therefore, sensitivity of galvanometer can be increased by decreasing radius and increasing number of turns. Therefore, option C, both A and B are correct. Therefore, we select option C. Question number 14. A transformer with 100% efficiency has 150 primary and 15,000 secondary turns connected to 150 volt mains. Then output potential difference per turn equals to how much? Option A 15 volts, option B 1.5 volts, option C 26 volts, and option D none. Solutions. Vs upon Vp equals to Ns upon Np. Vs we need to find. Vp given 150, Ns 15,000 implies Vs equals to 15,000 upon 150 into 150. This and this cut down. Therefore, we get Vs equals to 15,000 volts. Now, Vs per turn, so Vs upon number of turns, so 15,000 divided by 15,000 equals to 1 volt. Therefore, output potential difference per turn equals to 1 volt. Since output potential difference per turn is 1 volt, option A, option B and option C does not match. Therefore, we select option D, that is none. None of the above is correct answer. So we lock option D. Question number 15. A graph for stopping potential versus frequency of incident radiation for a photosensitive material is shown below. Then its threshold wavelength is. Option A 200 angstrom, option B 0.5 angstrom, option C 5,000 meters, option D 5,000 angstrom. Solution. Given threshold frequency 6 into 10 raised to 14 hertz, we need to find out threshold wavelength, that is lambda naught equals to question mark. So lambda naught given by C upon nu naught. So C value, that is the speed of light, 3 into 10 raised to 8 meter per second. So 3 into 10 raised to 8 upon 6 into 10 raised to 14, that is equals to 0.5 into 10 raised to minus 6 meter, converting into angstrom unit. Therefore 5,000 upon 1000 into 10 raised to minus 7, that is equals to 5,000 angstrom units. Therefore threshold wavelength is 5,000 angstrom units. So we lock option D. Question number 16. For a common emitter transistor circuit, collector resistance is 3 kilo ohms and base resistance is 2 kilo ohms. Audio signal voltage across collector resistance is 3 volts. Current amplification factor is 50. Then base current equals to how much? Option A 0.01 amperes, option B 2 into 10 raised to minus 4 ampere, option C 0.02 amperes, and option D 0.2 into 10 raised to minus 4 amperes. Here is the solution. Beta equals to 50 and V naught equals to IC into RC. Therefore IC equals to V naught upon RC, and V naught given as 3 volts and RC value 3 kilo ohms. Therefore IC equals to 3 upon 3 into 10 raised to 3, that is equals to IC equals to 10 raised to minus 3 amperes, and beta equals to IC upon IB equals to 50. Therefore we get IB equals to IC upon 50. So I see that is 10 raised to minus 3 divided by 50. So that is equals to 1 upon 5 into 10 raised to minus 4. That is equals to 0.2 into 10 raised to minus 4 ampere. Therefore, IB equals to 0.2 into 10 raised to minus 4 amperes. Therefore, option D is correct option. So we lock the option D. Question number 17. Material selected for making solar cell must have band gap between option A 0 electron volt to 1.8 electron volt, option B 6 electron volt to 100 electron volt, option C 1 electron volt to 1.8 electron volt, and option D none. Here is the solution. Material selected for making solar cell must have following properties. First property, band gap between 1 electron volt to 1.8 electron volt. Second requirement, it should have high optical absorption, and the third one, it should have high electrical conductivity and more other properties. Therefore, the correct option is C. Therefore, we lock option C here. That is, material selected for making solar cell must have band gap between 1 electron volt to 1.8 electron volt. Question number 18. Which of the following is same for all nuclei? Option A, density of nucleus. Option B, size of the nucleus. Option C, decaying power of nucleus. Option D, none. Solution. Rx is the radius of nucleus X, and Rx given by Rx equals to R0 a raised to 1 by 3, where R0 equals to 1.2 into 10 raised to minus 15 meters, and rho is equal to density inside the nucleus. So we have 4 by 3 pi r cube rho equals to MA. Therefore, rho equals to m into A upon 4 pi Rx cube, where Rx cube is equal to R. Therefore, rho equals to what? MA upon 4 pi. Now putting the value of Rx cube, that is R0 cube into A. So R0 cube into A get cancelled. Therefore, rho equals to m upon 4 pi R0 cube. Implies density does not depend upon A, depends on A. Therefore, density of the nucleus is same for all nuclei. Therefore, option A is selected. So we lock option A. Question number 19. Basically, choke coil is where L equals to inductance and R is resistance. Option A, with large L and small r. Option B, with small l and large r. Option C, equal L and r. Option D, with 0 L and r is large. Here is the solution. Choke coil, basically an inductor with large L and small r, that is large value of inductance and small value of resistance, in which power factor nearly equal to 0, and the inductive coil is wound on the soft iron core. Therefore, basically choke coil is with large L value and small r value. Therefore, option A is selected. Let us lock option A. Question number 20. If a charge Q is placed at central point of two charges of equal magnitude Q, all in a straight line, then charge Q equals to how much? Option A, Q equals to Q upon 4. Option B, Q equals to minus 4Q. Option C, Q equals to Q. Option D, none. Let the charges of capital Q placed at the point A and B, and the small charge Q placed at the central point, that is at the point C. Now apply the Coulomb's law. FAB equals to, and we obtain FAC. Since the charges are under equilibrium condition, therefore FAB plus FAC equals to 0. Implies Q square upon 4 pi epsilon naught R square plus Q into Q divided by 4 pi epsilon R by 2 whole square equals to 0, implies q square upon 4 pi epsilon r square equals to minus q into q upon 4 pi epsilon r upon 2 whole square. Both sides the similar terms get cancelled, so we get q equals to r square upon r square into 4. So r square get cancelled, so we get q equals to minus 4q. Therefore option B is correct option. Therefore we lock option B. Question number 21. Wavelength of sodium light is 640 nanometer in air, travels through glass plate of refractive index 1.6, then its wavelength equals to how much? Option A 256 nanometer, option B 400 nanometer, option C 64 nanometer, option D none. Here is the solution. Lambda A and lambda G be the wavelength in air and glass for the light. Lambda A equals to 640 nanometer and refractive index of glass equals to 1.6. We use the relation lambda G upon lambda A equals to mu A upon mu G. Therefore, lambda G equals to lambda A multiplied by mu A upon mu G. So that is equals to 640 into 1 upon 1.6. Lambda G equals to 400 nanometer. Therefore, wavelength of light in glass is 400 nanometer. Option B is correct option. Therefore, we lock option B. Question number 22. The radius of first Bohr orbit in hydrogen atom is 0.52 angstrom units. Then radius of third Bohr orbit equals to how much? Option A 0.477 angstrom units, option B 4.77 angstrom units, option C 47.7 angstrom units, option D none of the above. Here is the solution. R is proportional to n square. R1 equals to 0.53 angstrom units. We need to find R3, and the relation is R3 upon R1 equals to n3 square upon n1 square. Therefore, R3 equals to n3 square upon n1 square into R1. Therefore, R3 equals to 3 square upon 1 square into 0.53. So we get R3 equals to 4.77 angstrom units. Therefore, the radius of third Bohr orbit equals to 4.77 angstrom units. Therefore, option B is correct option. We lock option B here. Question number 23. Dimensional formula for electric potential equals to how much? Here is the solution. Electric potential equals to work done upon charge. So V equals to m L square T raised to minus 2 divided by A T. So V equals to m raised to 1, L raised to 2, T raised to minus 3 and A raised to minus 1. This is required dimensional formula for electric potential. Therefore, option C is correct option. That is, dimensional formula for electric potential is m raised to 1, L raised to 2, T raised to minus 3, A raised to minus 1. Therefore, we lock option C. Question number 24. For a rectifier, relation for ripple factor is option A, ripple factor equals to IDC upon IAC. Option B, ripple factor equals to IDC multiplied by IAC. Option C, ripple factor equals to twice IDC upon thrice IAC. And option D, ripple factor equals to IAC upon IDC. Here is the solution. Ripple factor measures quantity of AC in a DC output. Therefore, ripple factor equals to IAC upon IDC. Therefore, ripple factor equals to IAC upon IDC. Therefore, option D is correct. So we lock option D, ripple factor equals to IAC upon IDC. Question number 25. An electron has kinetic energy of 169 electron volts. Then its de Broglie wavelength equals to how much? Option A 0.142 angstrom units. Option B 0.943 angstrom units. Option C 5.05 angstrom units. And option D 1.156 angstrom units. Solution. Accelerating potential difference is given by kinetic energy upon E. So we get accelerating potential difference 169 volt. Now de Broglie wavelength. Lambda equals to 12.27 upon under root of V. The result would be in the angstrom units. This is equal to 12.27 upon under root of 169, that is equals to 0.943 angstrom units. Therefore, de Broglie wavelength equals to 0.943 angstrom units. Therefore, option B 0.943 is correct option. Therefore, we lock option B. Question number 26. A dipole of dipole moment 2 into 10 raised to minus 8 coulomb meter rotated from 0 degree to 180 degree in presence of uniform electric field of intensity 10 raised to 3 Newton per coulomb. Then work done in rotating dipole is option A 0 joules, option B 4 into 10 raised to minus 5 joules, option C 1.6 into 10 raised to minus 15 joules, option D none. Here is the solution. Theta 1 0 degrees, theta 2 180 degrees, and P value 10 raised to minus 8 coulomb meter, and E equals to 10 raised to 3 Newton per coulomb. Now work done. Formula is nothing but PE and cos theta 1 minus cos theta 2. This relation we use here. So putting these values, this is equals to 2 into 10 raised to minus 5, 1 minus 1 equals to 4 into 10 raised to minus 5 joules. Work done equals to 4 into 10 raised to minus 5 joules. Therefore, work done in rotating the given dipole is equals to 4 into 10 raised to minus 5 joules. Therefore, option B is correct. We lock option B. Question number 27. The refractive index of a glass if polarizing angle is 60 degree. Option A 1.4, option B 1.732, option C 0.577, option D none. Here is the solution. Relation between refractive index and polarizing angle is given by Ng equals to tan theta B. Polarizing angle is given as a 60 degrees. Therefore, refractive index of glass tan 60 equals to 1.732. Therefore, refractive index of the glass 1.732. Therefore, correct option is B. So we lock the option B. Question number 28. The SI unit of electric flux. Option A Newton meter square per coulomb. Option B voltmeter. Option C both A and B. Option D none. The correct option is the SI unit of electric flux is both Newton meter square per coulomb as well as voltmeter. Therefore, the option C is correct, both A and B. So we select the option C. We lock the option C here. Question number 29. Correct set of polar and non-polar molecule respectively is option A HCl H2O, Option B, H2 and CO2. Option C, CO2 and HCl. And option D, HCl and CO2. Solution: HCl and H2O are polar, H2 and CO2 are non-polar. We have to select first polar molecule, that is HCl. Then we have to select non-polar molecule, that is CO2. Therefore, the first is a polar. So here is a polar, but here is also polar. So option A is not selected. Option B, H2 and CO2 both are non-polar. Option B also not selected. CO2 and HCl. First we want the polar, therefore this option is also not correct. Therefore we select the option D, that is the HCl and CO2. Therefore option D, HCl and CO2 is the correct option. Question number 30. Dash works on the principle of corona. Option A, cyclotron. Option B, Van de Graaff generator. Option C, electron microscope. Option D, telescope. Here is the solution. Corona effect is nothing but electric charges readily discharged at sharp edges and sharp points. So this is the principle used in Van de Graaff generator. Therefore, we select option B. Question number 31. A charged particle entering magnetic field at an angle less than 90 degrees. Then it will describe the path during its motion. Option A, circular path. Option B, helical path. Option C, hyperbolic. And option D, parabolic. Here is the solution. When a charged particle enters uniform magnetic field, if theta equals to 90 degrees, then the charged particle performs circular motion, and if theta less than 90 degrees, the charged particle performs helical motion. That is, charged particle performs circular motion if it enters at angle 90 degrees to the field, and it performs helical motion if it enters less than 90 degrees, that is obliquely. It will move like this, helical motion. Therefore, option B is correct option. So we lock option B. Question number 32. When a trivalent impurity added to pure semiconductor, then conduction takes place due to option A, holes. Option B, electrons. Option C, no conduction. And option D, first holes then electron. Here is the solution. Whenever a trivalent impurity is added to a semiconductor resulting into p-type semiconductor, it has holes as a majority charge carriers when we add small amount of trivalent impurity. Therefore, option A is correct option, so we lock option A. Question number 33. Polarizing angle of a transparent medium is 55 degrees. Then the angle of refraction equals to how much? Option A, 35 degrees. Option B, 135 degrees. Option C, 125 degrees. Option D, none. Here is the solution. Polarizing angle plus angle of refraction equals to 90 degrees. Therefore, R equals to 90 minus polarizing angle. R equals to 90 minus 55. R equals to 35 degrees. Therefore, correct option is option A. So we lock option A. Question number 34. If VAB equals to 10 volts per given circuit, then energy stored equals to how much? Here in the circuit, each capacitor equals to 2 microfarad. Option A, 1.11 joules. Option B, 65 joules. Option C, 0.04 joules. And option D, none. Here is the solution. First of all, we find out equivalent capacitance, that is 4 upon 5 into 10 raised to minus 3 farad. Then energy stored in the capacitor, half CV square. Putting the values, we get energy stored in the entire circuit E equals to 0.04 joules. Therefore, we lock option C, that is energy stored in the given circuit is 0.04 joules. Question number 35. The resolving power of a telescope if radius of lens is 1.22 meters and wavelength of incident light is 6000 angstrom units. Option A 0.16 into 10 raised to minus 5. Option B 0.16 into 10 raised to 5. Option C 16 into 10 raised to 5. Option D none. Resolving power of telescope is equals to D upon 1.22 into lambda. So D value is 1.22 upon 1.22 multiplied by lambda, that is 6000 into 10 raised to minus 10, because it is given in terms of angstrom, so convert into the meters. On simplification, it gives 16 into 10 raised to 5. So this is the value of resolving power of telescope. Therefore, option C is correct option. So we lock the option C, that is resolving power of telescope is 16 into 10 raised to 5. Question number 36. Which of the following increases in case of step down transformer? Option A voltage, option B supply frequency, option C current, option D all. Here is the solution. In case of step down transformer, on primary side the number of turns are more, on secondary side number of turns are less. On primary side more voltage and secondary side less voltage. But in case of step down transformer, the corresponding value of current on secondary side is more compared to the primary side. Therefore, in step down transformer, voltage decreases and corresponding current increases. Therefore, option C is correct option. Question number 37. The ratio of energies of the hydrogen atom in its second to third excited states is option A 16:9, option B 9:16, option C 4:3, option D 3:4. Here is the solution. Energy of electron in nth orbit of hydrogen atom given by En equals to minus 13.6 upon n square, and the unit is electron volt. We need to find out E2 upon E3. So E2 upon E3 equals to n3 square upon n2 square, that is equals to 4 square upon 3 square equals to 16 upon 9, implies the ratio of energies second energy level, second excited state to third excited state is 16:9. Therefore, option A is correct option. So ratio of energies of hydrogen atom in second to third excited state is 16:9. We lock option A. Question number 38. If the radius of Earth suddenly shrinks to half, mass remaining same, then Earth magnetic field at equator changes by dash times. Option A 8, option B doubles, option C triples, option D becomes half. The value of Earth magnetic field at equator is given by mu naught m upon 4 pi r cube, where m is the mass of the Earth and r is the radius of the Earth. So we have B equator mu naught m upon r cube, and after shrinking of the Earth, let us call it as a Earth magnetic field 2, and it is a 1, it is a r1, and m1 is remaining same, mass is not changing, only the radius is changing. Therefore r2 cube dividing first by second, we get mu naught m upon 4 pi r1 cube divided by mu naught m upon 4 pi r2 cube. These terms get cancelled, so we get here B equator 1 to B equator 2 equals to r2 cube upon r1 cube, but r2 is half of the r1, therefore B equator 1 to B equator 2 equals to r1 upon 2 whole cube divided by r1 cube equals to 1 upon 8, implies B equator at 2 is nothing but 8 into. Therefore after the radius of the earth becomes half, the earth magnetic field increases by 8 times. Therefore, if the radius of the earth suddenly shrinks to half, the mass remaining same, then earth magnetic field at equator changes by 8 times. Therefore, we lock option A. Question number 39. The basic function of a transducer is option A to convert one form of energy to other form, option B to stop energy, option C to increase energy, option D to decrease heat. Here is the solution. A device that converts one form of energy into another form of energy is called as a transducer. Therefore, the basic function of transducer is to convert one form of energy to another form. Therefore, option A is correct option. Question number 40. An electric heater takes 5 ampere of current from 220 volt supply line. The electric energy consumed by heater in 2 hours is how much? Option A 100 kilowatt hour, option B 110 kilowatt hour, option C 2.2 kilowatt hour, and option D 1.1 kilowatt hour. Solution. Current is 5 amperes and supply voltage 220 volts. Power equals to product of current and voltage, so that is 5 into 220, so P equals to 1100 watts. Now converting into kilowatts, so 1100 divided by 1000, so that is equals to 1.1 kilowatts. Now energy consumed equals to power into time, that is equals to 1.1 into 2, so that is 2.2 kilowatt hour. Therefore, electric energy consumed by heater in 2 hours is 2.2 kilowatt hour. Therefore, option C is correct. So we lock option C. Question number 41. In case of Fresnel biprism, vertex angle nearly equals to option A 18 degrees, option B 30 minutes and 1 degree, option C 180 degrees, and option D 90 degrees. Here is the solution. In a Fresnel biprism, vertex angle nearly equals to 180 degrees. It can be considered as a combination of two prisms with small refracting angles from 30 minutes to 1 degree. Therefore, in a Fresnel biprism, vertex angle nearly equals to 180 degrees. Therefore, option C is correct. We lock option C. Question number 42. If 200 joules of work is done to take a charge of 10 coulombs from point A to point B, potential at point A is 20 volts, then find potential at point B equals to how much? Option A 20 volts, option B 0, option C 40 volts, option D none. Here is the solution. We know that VB minus VA equals to work done upon charge. So we need to find VB. VA is 20 volts, work done is 200, and charge is given 10. So we get VB equals to 40 volt. Therefore, option C is correct option. So we lock the option C. Question number 43. In polar molecules, option A, center of mass of positive and negative charges coincide. Option B, they have asymmetric shape. Option C, both A and B. Option D, none. Here is the solution. In polar molecules, center of mass of positive charge does not coincide with, here is the important, here is a does not coincide with the center of mass of negative charge because of asymmetric shape of molecules. So the option B, that is polar molecules have a symmetric shape. Therefore we lock option B. Question number 44. Loop equation for closed path ABCDA is. Here is a circuit diagram given. We need to find the loop equation for closed path ABCDA. For closed loop ABCDA, for path AB, we are moving in the direction of current, therefore minus I1 R1. For path BC, even we are moving in the direction of current, therefore I2 R5. And for path CD, even we are moving in the direction of current, minus I1 R2. And for path DA, we are moving from lower potential to higher potential, so plus E1. Now adding all this equation, so we get minus I1 R1 minus I2 R5 minus I1 R2 plus E1 equals to 0. This is required loop equation for closed loop ABCDA. Therefore, we select option B. Question number 45. What should be the value of shunt resistance so that only 10% of current flows through galvanometer of 100 ohms? Here is a circuit diagram provided. With the help of circuit diagram, we need to find the value of shunt resistance. Here is the solution. G into Ig equals to S into Is, because they are in parallel. Therefore, S equals to G into Ig divided by Is. Call it equation number 1. From figure, Ig plus Is equals to I. Therefore, Is equals to I minus Ig. Given only 10% of current is flowing through the galvanometer, therefore Ig equals to I upon 100 into 10 equals to 0.1 I. Therefore, S equals to G into Ig upon I minus Ig, that is 0.1 I. Therefore, S equals to G into Ig. Ig nothing but 0.1 into I divided by I into 0.9. I get cancelled. Given G is 100, 100 into 0.1 divided by 0.9, that is equals to 11.11 ohms. This is required value of shunt resistance. Therefore, option D, that is 11.11 ohms, is a correct solution. Therefore, we lock option D. Question number 46. If a circular copper coil has 350 turns and a current of 0.1 ampere passed through the coil, if area enclosed by the coil is 2 into 10 raised to minus 3 meter square, then magnetic moment of the coil equals to how much? Option A, 350 ampere meter square. Option B, 0.07 ampere meter square. Option C, 14 ampere meter square. Option D, none. Here is the formula. Mu equals to NIA. Please do calculation and write down correct option in the comment box. Question number 47. The coefficient of coupling is 0.6 for two coils of self-inductance 144 millihenry and 9 millihenry respectively. Then mutual inductance of the coils equals to how much? Option A, 216 millihenry. Option B, 21 millihenry. Option C, 562 millihenry. And option D, 256 millihenry. Viewers, please do the calculations, decide the formula and write down the correct option in the comment box. Dear students, after going through 46 questions, 47, 48, 49, 50, these few questions I am giving you to test your understanding. Please decide the correct option and write down correct option in the comment box. Question number 48. In case of an ideal inductor or an ideal capacitor circuit, power over a complete cycle is Option A is 0. Option B infinity. Option C product of L and C. Option D none. I hope you will find the correct answer, and you will also write down your answer in the comment box. Question number 49. In case of a parallel resonance circuit, option A impedance is maximum, option B current is minimum, option C both A and B, option D none. Question number 50. Relationship between de Broglie wavelength and linear momentum is given by. There are the 4 options. Please select the correct option and write down your option in the comment box. If you try these 4 questions and give me the correct answer, I hope my efforts to provide these question papers are really successful. If you find content in this video are helpful to you, they will help you to score more in your examination, then I request you, please forward this video to your friends, share with your friends, like and share the channel and subscribe the channel so that you will get more better videos in coming future. For more educational resources, please keep on watching this channel. Meet you again with another topic. Till then, wish you good luck. All the best.